Right. Now let's move to the MCQ number 6. The gold leaf experiment done by Rutherford using alpha particles explains that the atom consists of electrons. What do you think? No, gold leaf experiment, that means gold foil experiment is not explaining something like that. In the gold foil experiment, we learned that students, he's mainly explaining about the atomic nucleus, right? He mainly explained about the atomic nucleus, right? So therefore, no, it's not about the atom consists of electrons. We know that electrons are existing, but it's not what he explained using the gold foil experiment. The mass of the atom is considered into a point and the volume of it is very small. Yes, exactly, right? So if you can remember, when you consider the atom, so the nucleus is very small particle there. So therefore, a point mass, right? If you can remember in the theories, we learned that atomic nucleus is a point mass. So this is the atomic nucleus. So therefore, that statement is correct. Atom are building units of matter. Yeah, that's also correct, according to the Dalton's theory. Neutrons are found in atoms. Now, we can say something like this. Neutrons are found in atoms. Tell me, students, what is the issue with this statement, as you think? Is this statement correct, as you think? Neutrons are found in atoms. Is this correct? Yeah, neutrons are found in nucleus. Okay, fine. But is this correct at all time? There is an element, hydrogen. We know that hydrogen is there, right? So hydrogen doesn't contain neutrons, right? Neutrons are found in atoms is not valid for the hydrogen atom. Okay. Atom means hydrogen is also included there. Hydrogen atom is also there. Right. So therefore, we can't say that this statement is correct at all. Right? Not found in hydrogen atoms. Okay. So therefore, I'm going to consider this statement is wrong statement. Therefore, answer is number 2. B and C correct. Therefore, answer is number 2. Okay. So you can argue with me, right? In the statement questions, we have to be very careful because they are giving a small, sometimes the statement is completely becoming wrong, incorrect or correct because of just one word. So therefore, we have to be very careful. Okay. Now let's move to the MCQ number 7. The false statement regarding the following a statement is every atom in an element has an equal number of electrons in each of them. Is it correct? What do you think? Every atom in an element has an equal number of electrons in each of them. Is this statement correct? What do you think? Yeah, that's correct. Every atom in an element has an equal number of neutrons. No, because of isotopes. We know that when you consider a particular element, there can be two different isotopes, right? We know that isotopes means they're having the same atomic number, different mass numbers. So therefore, we can say that they're having different number of neutrons. It should not be equal number of neutrons, right? So therefore, that's a false statement. Every atom in an element has equal number of protons. Yeah, that's correct. Every atom in an element has equal number of nucleons. We know that nucleons means, can you remember? Nucleon means summation of protons and neutrons. Since the neutron count can be changed because of the isotopes, nucleon is also changing. So therefore, that is also true. In an element, the atomic number is equal to the number of electrons it has in an atom. Okay. Now, in an element, the atomic number is equal to the number of electron it has in an atom. What do you think? Is this correct? Yeah, that's fine, no? Because if it is a neutral one, that's fine. Okay, but they haven't given neutral, but we have to assume this is atom, right? So it's a neutral one. So that's correct. So here there are two answers, number 2 and number 4, because they're asking false statement, right? The atom was first articulated to the world by Cannizzaro, Dalton, Debonnier, Avogadro, Mendeleev. Who is it? Dalton. Rutherford's goal foil experiment revealed that quite a large space of matter is empty. The positive charge is considered as nucleus. Both the statements are correct, right? In the Rutherford's goal foil experiment, the first observation was, first conclusion was most of the space in the atom is empty because most of the alpha particles are penetrating through the gold foil without any deflection. So he decided that most of the space in the atom is empty. And there is a small area that positively charged inside the nucleus. So it was named as atomic nucleus. Only a thin layer can radiate particles. Only a thin layer can radiate. This should be alpha particles. Okay. What do you think? Only a thin layer can radiate alpha particles. Is it correct? What is your opinion? MCQ number 9. Only a thin layer can radiate alpha particles. These statements, they have given the electrons move in quantized energy levels. Can you remember, students, when we discuss about the penetrating ability? Okay. Alpha, beta, gamma. We discussed that penetrating ability is high in gamma. Then ionizing ability is high in alpha. So therefore, only a thin layer can radiate alpha particles is correct. Nothing wrong with that statement. The next thing, the electrons move in quantized energy levels, right? Quantization, that means we know that in the Bose model, we discussed that electrons are revolving around the nucleus in particular energy levels, right? Then we discuss about the quantized energy also, right? So therefore, that's correct. A, B, C, D statements are correct. Therefore, answer is number 4. MCQ number 10. The mass of an electron is. So we know that students' mass of an electron is 9.107 10 to the power minus 31 kilograms. But here they have given the answer in grams. 9.107 10 to the power minus 28 grams. So answer is number 3. That's very easy. The true statement or statements regarding alpha particle, right? Correct that one, alpha particle. Alpha particle is up. Alpha particles take up electrons to make helium molecules. Correct that one as helium nucleus, okay? Helium nucleus. What do you think? Is it correct? Alpha particles take up electrons to make helium nucleus. Alpha particles take up electrons to make helium nucleus. Is it correct? No. Helium molecules. It's better if they have given this one as helium atoms, not molecules. Yeah. Now, okay. We know that alpha particle means, students, helium nucleus. That means helium 242 plus. Okay. Yeah. For the ninth one, answer should be number 5 because ABCD statements are correct. So therefore, answer is number 5. Now, MCQ number 11, simple A statement. Alpha particles take up electrons to make helium atoms. That's correct, students, because look at this one. Helium nucleus means alpha particle means helium nucleus. That means there are no electrons. If it is taking electrons, just imagine if you take, if that helium atom is, helium nucleus is taking 2 electrons, then it can be converted helium atoms. Okay. So therefore, simple A statement is correct. The penetrating power of alpha particles is very small. Just now we discussed that one. We know that penetrating power of alpha particle is very small. The ionizing power of alpha particles is very small. That's wrong. Alpha particles are having high ionizing power. Alpha particles move towards north pole in a magnetic field. Wrong, right? Negatively charged particles or positively charged particles are moving to a perpendicular direction in the presence of a magnetic field. So therefore, this is not correct. A and B statements are correct. Therefore, answer is number 1. A and B statements are correct. Therefore, answer is number 1. Right. Students, let's skip question number 12 because they have given the new stand used to express the relative atomic mass. The answers are also not relevant answers. So let's skip that question number 12. Let's move to the MCQ number 13. The quantity of the electronic charge was experimentally shown by Millikan. The penetrating power of alpha particle is greater than that of beta particles. Is it correct? What do you think? The penetration power, just now we discussed, penetration power alpha particle is greater than that of beta particles. That's wrong. The mass of the alpha particle is very much greater than the mass of beta particles. What do you think? We know that when you consider alpha particles are containing, alpha particles means helium nucleus, 2 protons and 2 neutrons. Okay. Alpha particle is containing 2 protons and 2 neutrons. Then beta particle means what? Beta particle means just electron, 1 electron. So therefore, alpha particle is having a greater mass than beta particle. Therefore, the second statement is correct. Then tell me what is the option we have to choose. First statement is wrong. Second one is correct. Then what is the answer? First statement is wrong. Second statement is correct. Then what is the answer? Answer is number 4. Okay. Option number 4. Right. The charge to mass ratio of the electron was experimentally determined accurately by whom? Millikan. Is it Millikan? Thomson. Okay. If you can remember the value of charge to mass, 1.759 10 to the power 11 coulombs per kilogram. Right? Charge to mass ratio. Question number 16. The isotopes of a given element have the same number of neutrons. Wrong. Have the same number of electrons. Correct. Have the same number of protons. Correct. Have the same number of nucleons. Wrong. So therefore, B and C statements are correct. If B and C statements are correct, answer is number 2. Which one of the following statements concerning a beam of electrons is true? It is attracted towards the cathode. We know that electrons are negatively charged. Cathode is also negatively charged. Then electrons cannot be attracted towards the cathode. It is attracting towards the anode. That is wrong. It is attracted towards the N pole, north magnetic pole, and it is attracted towards the south magnetic pole. We know that electrons are moving towards a perpendicular direction of the magnetic field, not for the neither north pole nor south pole. Both the statements are okay. Then it is deflected away from the anode. No, actually it is deflected towards the anode, because this is actually a beam of electrons, negatively charged one. They are not going away from the anode. That's wrong. Then all of the above statements are false. Yeah, that is the correct answer. Number 1, number 2, number 3, number 4, all of the statements are wrong. E of M value for the electron was experimentally determined accurately by, so again we discussed that one. It is Thomson, but Thomson's is not given. Millikan, Crookes, Rutherford, Marsden. So therefore none of the above. Answer is Thomson. Right. Now look at this one. MCQ number 90. Naturally occurring carbon contains 98.89% of carbon 612 isotope, 1.11% of carbon 613 isotope. The relative atomic mass of carbon 613 is 13.033. Okay. The relative atomic mass of naturally occurring carbon is right. Relative abundance question. They have given the relative abundance and the isotope. Here also relative abundance and isotope is given. So let's do the calculation. Let me put the page number and the question. Page number 4, question number 90. So we know that they have given carbon 612 isotope and its relative abundance is 98.89. So very large value, right? Then carbon 613, it is 1.11. Yeah, 100 minus this value is 1.11. Then if you can remember average relative atomic mass, can be found mass number multiplied by the relative abundance value of the first isotope, then 13 multiplied by 1.11 divided by 100. Okay. So when you do the simplification, you will get here 1201.1 divided by 100. So therefore answer should be 12.01. Yeah, this should be the answer, right? Exactly. We know that carbon's relative atomic mass is 12. Okay. So average relative atomic mass of carbon is 12. Check whether they have given this answer. 12.0111. Have they given this answer? Yeah, the fourth one is the answer, right? Fourth one is the answer, right? MCQ number 19. Fourth one is the answer. Right. The confusion that existed among chemists at the early stages of a study of chemistry regarding the concept of atomic weight was dispelled by who? So actually the answer is Canizaro. Okay. So we didn't learn these theories because this is actually very old syllabus 1996. But you remember that. So the answer is actually Canizaro. MCQ number 21. The atomic mass unit is accepted as 1.66 10 to the power minus 24 grams. Yeah, that's correct. Actual answer should be 1.661. Right? Yeah, but it's okay, fine. That's correct. First statement is correct. While exactly 1/12 of the mass of a carbon atom is taken as the atomic mass unit, there are 6.022 10 to the power 23 carbon atoms in exactly 12 grams of carbon. What do you think? Is it correct? While exactly 1/12 the mass of a carbon atom is taken as the atomic mass unit, small issue is there. We know that they have to specify the isotope. Carbon atom means we can take carbon 613 also, right? Atomic mass unit means exactly 1/12 of the carbon 612 isotope, right? Remember, students, when we are defining the atomic mass unit, okay, we have to define it like this, right? Remember, how do you define the atomic mass unit? Atomic mass unit. Atomic mass unit means we have to tell 1/12 of the mass of carbon 612 isotope. You have to specify that, because if you say commonly carbon atom, it is representing carbon 613 also. Therefore, because of that, this statement is wrong. Otherwise, having Avogadro number of atoms in 12 grams of carbon, that part is correct. The second part of the statement is correct, but the first part is wrong. Therefore, I have to consider that statement is wrong. First one is correct, second one is wrong. So therefore, answer is third one. MCQ number 22. The size of the atomic nucleus was first determined by making use of alpha particle scattering, right? So that is the answer, right? Nucleus gold foil experiment. Actually, we don't have to look at the other answers also, right? Beta particles using high speed electrons, neutron beams, making use of alpha particle scattering. Both the answers are same. Number 1 and number 5 both are same, right? So actually, we found the atomic nucleus by using alpha particle scattering. The experiment is gold foil experiment conducted by Ernest Rutherford with the help of his two students, Geiger and Master, right? These are simple theories that we learn. Right, okay. Now MCQ number 23. Which one of the following statements concerning the particles used by Geiger and Marsden in the experiment that provided the basis for the nuclear model of the atom is most appropriate? Accelerated particles were used by Geiger and Marsden. So accelerated particles, actually they have mentioned alpha particles. So what accelerated particles? So therefore we can't accept this. Cathode rays were used? No. Accelerated cathode ray particles were used? Wrong. Accelerated neutrons were used by Geiger and Marsden? Wrong. All of the above statements are incorrect. Yes, that is the answer. For the determination of atomic numbers of the elements, emission spectra were used. Emission spectra and absorption spectra were used. X-ray spectra were used. Mass spectrometer was used. None of the above method was used. Can you remember in the theories I told you that atomic number was found by X-ray spectroscopy. So therefore answer is third one. Which of the following statements concerning electrons are true? Electrons want to move in a curved path in a magnetic field. Yeah, that is exactly correct. Okay. I told you that electrons are moving to a perpendicular direction, right? But remember, students, that perpendicular direction should be a curved path. That's correct. Electrons have both particle and wave properties. That's also correct. In the de Broglie's equation, we learned that lambda equal h of mv. So it has particle nature and wave nature also. Electrons cannot be added to or received from an atom. No. Otherwise, how anions, cations are produced? That's wrong. The speed of electron is equal to the speed of light. Wrong. It should be 90% of speed of light. Okay. Can you remember for the beta particles I gave you the speed is 90% of speed of light. So therefore, first one and the second one correct. Both the statements are correct. Chemical and physical properties of isotopes are similar. Yeah, that's correct. Isotopes have the same number of protons but different number of neutrons. Is it correct? Isotopes have same number of protons but different number of neutrons. Yeah, isotope means we know that same number of protons, different number of neutrons. That's what we call that one as isotope. Now the first statement is wrong because chemical properties are same. Okay. But physical properties are different. So therefore first statement is wrong. Okay. Chemical properties are same, but physical properties are different because of the number of neutrons. Second statement is correct. First one is wrong, second one is correct, then answer is number 4. Right? Which of the following gas deflect when moving across a magnetic field? Remember, students, in order to deflect through a magnetic field and an electric field, the condition should be the particle is charged particle. Neutron is neutral particle. Cathode ray is negatively charged. Proton is positively charged. Helium atoms are neutral. Then B and C, cathode rays and proton, they can deflect when going through magnetic field. Right? That's correct. B and C. Try to understand the question now. They are asking whether they are deflecting or not. That's all. Yes, cathode rays are negatively charged. Protons are positively charged. Anyhow, both of them are charged particles. They can move. They can deflect. What about the next one? A certain sample of carbon monoxide has only carbon 614 and oxygen this one should be corrected as oxygen 8 and 16. Okay. Now, okay. A certain sample of carbon monoxide has carbon 614 and oxygen 816 isotopes. Another sample of carbon monoxide has carbon 612, oxygen 818 isotopes only. The property that shows significant difference between the two samples is, that means, students, they have mentioned here. Now, this is carbon monoxide, sample of carbon monoxide. One is containing carbon 614, oxygen 816. And here in another sample, here carbon 612, and here oxygen 818. The property that shows a significant difference in between the two sample is chemical reactivity. We know that chemical reactivity, isotopes, chemical reactivity is same, right? There is no difference. What about the molar mass? Is there a difference in the molar mass? Now, students, when you consider the masses here, carbon is 14, oxygen is 16, therefore mass is 30. Here carbon is 12, oxygen is 18, mass is 30. Okay. So therefore, no much difference. Okay. The next one is molar volume. Right? Molar volume. In molar volume, will there be any difference? Molar volume means actually volume of 1 mole. Okay. So in molar volume, there is no much difference. Density. Density is also fine. No difference. The next one, percentage composition of carbon and oxygen by mass. Now here there will be a difference. The reason is when you consider carbon monoxide molecule. Now here carbon's mass is 14. Right? Then here carbon's mass is 12. So when you consider separately carbon and oxygen, their masses are different. Then percentage composition of carbon and oxygen by mass, different. There will be a significant difference in there. Answer is number 5. Okay. Because students, when you consider carbon monoxide molecules, even though that they have same different number of mass numbers, when you consider carbon monoxide molecules together, anyhow the mass number is 30. Here 14 and 16 mass number 30. Here 12 and 18 mass number 30. Right? Answer is number 5. What about the MCQ number 29? Can you tell me the answer for MCQ number 29? Which of the following statements is or true? An atom. Yes. Let's see. Atom of tin. Right? So this is the element tin. 50, 180. How many electrons are there? 50. How many protons are there? 50. How many neutrons are there? We can say 68. It has 50 electrons, correct? 50 protons, correct? It has total number of 118 electrons and protons. No. Electrons and protons. It has a total number of 118 electrons and protons. Electron and proton count is 100, right? So therefore, that's wrong. It has 68 neutrons, correct. ABD statements are correct. If ABD statements are correct, what is the option that I told you to take? ABD. If ABD statements are correct, what is the option? Option number 5. Any other option? Yeah, right? Easy. Now, let's move to the MCQ number 30. Which one of the following column 1 to 5 correctly matches the name of each scientist in the column with the activities in the activity column? So what are the activities they have given? Propose the nuclear model of the atom. So who proposed the nuclear model of the atom? Rutherford, right? Then interpreted the atomic spectrum of hydrogen? It is Niels Bohr. Then the third one is determine the charge to mass ratio of the electron. That is Thomson. So therefore, Rutherford, Bohr, and Thomson. Answer should be second one. Which of the following statement these are true? Electrons have particle as well as wave properties. Correct. A proton is heavier than the neutron. What is the mass of proton? 1.672 10 to the power minus 27 kilogram. Mass of a neutron is 1.675 10 to the power minus 27. Proton is not heavier than neutron. Wrong. All atoms have electrons, protons, neutrons. Can you remember? Hydrogen doesn't contain neutrons. Wrong. All ions have at least one proton. That's correct. A and B statements are correct. A and D statements are correct. Then what is the option? Number 4. Is it clear? Right? A and D statements are correct. Therefore, answer is number 4. So the next one. Which of the following statements incorrect? Now, students, remember when you read the questions, check whether they are asking incorrect statements or correct statements, true statements or false statements. Okay, so analyze that one very carefully. Read the question. Okay. The same number of electrons. Are they having same number of electrons? Yes. The same density? No. Because density means what? Physical property. So therefore, not same density. Similar chemical properties. Different number of neutrons. Correct? Yes. Same number of new protons. Correct. They're asking incorrect statement. Therefore, answer is number 2. In the question, they're asking incorrect statement. Therefore, answer is number 2. Put the answers for the question number 33 in the chat box. That's very easy. What is the answer? Yes, very good. Your answers are correct. Farah, your answer is correct. Aina, your answer is correct. Hafsa, your answer is correct. Bilal, your answer is correct. Sinatul, check the answer. So this is about magnesium 2 plus, right? Magnesium 2 plus 1225. So we know that, look at this. Yeah, Akifa, your answer is correct. Magnesium atomic number is 12, mass number 25, 2 plus. If it is magnesium atom, we know that. Yeah, now your answer is correct, Sinadul. Sanya, your answer is correct. There are 12 electrons in the neutral atom, but this is the cation. 2 electrons are removed, therefore 10. How many protons? 12. How many neutrons? We can say 30. Then they're asking electron count and the neutron count. So therefore 10 and 13. Answer is number 3. Very easy. Very simple. So this is an O-level question, right? 2007 A-level exam. See, 2007 A-level MCQ number 4. Now we can't expect these kind of questions. Okay, I'll discuss recent also at the end, but this is actually kind of a warm up. That means you have to understand the theories. So we are revising the theories while discussing the questions. Okay. Of the following scientists, identify who was not connected with the development of the atomic theory. Niels Bohr contributed by introducing the energy level model. J.J. Thomson is the major contributor. Chadwick, he found the neutron, so he also contributed. Rutherford is also very important. He played a very important role. Linus Pauling. Who is this Linus Pauling? Linus Pauling is the scientist who found the electronegativity table, a quantitative value for the electronegativity. So there is no contribution from him for the development of atomic theory. Okay. So he has a huge contribution to the chemistry, but not for the atomic theory. Yeah? Then answer is Linus Pauling. MCQ number 35. Which of the following statements is not true regarding subatomic particles? Electrons show both wave and wave properties and particle properties. It's correct. Electron is I think in this statement they are trying to say electrons are dispersed in three-dimensional regions of space around the nucleus referred to as an orbital. Yeah. Let me correct that one in this way. In this way. Yes. We know that atomic orbital means the place where we can find out the electrons with the maximum probability. So therefore, that's correct. The neutron was detected when beryllium was bombarded with high energy alpha particles, helium nucleus. Yeah, can you remember the reaction? What is the discovery of neutron reaction? Beryllium plate, beryllium 49, bombarded with alpha particles, alpha 24, producing carbon 612 and neutron 01. So therefore, this is the nuclear reaction which is taking place in the production of neutron. Therefore, third statement is also correct. The neutron is an uncharged particle with its mass approximately equal to that of the proton. Of the proton. The neutron is an uncharged particle with its mass approximately equal to that of the proton. Approximately correct, no? Again, let's revise. What is the charge of, what is the mass of proton? 1.672 10 to the power minus 27 kilograms. What is the mass of neutron? 1.675 10 to the power minus 27 kilo. Approximately equal. Correct. The number of protons in isotopes of an element are different from each other, not the protons. It should be neutrons, right? In isotopes, the different number of subatomic particles are neutrons. Therefore, answer is number 4. The neutron was discovered by Niels Bohr, Ernest Rutherford, James Chadwick, Albert Einstein, Eugene Goldstein. James Chadwick. The plum pudding model of atomic structure was put forward by whom? J.J. Thomson. Easy. Now we have a calculation. The energy of one photon, right, of this green light is when lambda is 442 nanometers. Right. Shall we do the calculation? 442 nanometers. Page number 7. Question number page number 7. Question number 38, right? Yes. (442 nanometers lambda). Students, we learned that in unit number 1, energy of a photon can be calculated using equal hc over lambda equation. H means Planck's constant, 6.626 10 to the power minus 34 joule seconds. C means velocity of light, 3 into 10 to the power 8 meters per second. Lambda 442, that means I can say 4.42 10 to the power minus 7 meters. Meters cancel off, second per second will cancel off. 6.626 multiplied by 3 divided by 4.42. Then here 10 to the power minus 7 will go to the numerator as 10 to the power plus 7. Then 10 to the power plus 15. Then already 10 to the power minus 34 is there. Then we can say 10 to the power minus 19 joules. Right? Now do the simplifications. (19.878) divided by you will get the answer 4.497. So let's take approximately 4.5, right? In kilojoules, how much? 4.5 10 to the power minus 22 kilojoules. Is the calculation. Right. So here we can consider the answer 4.5 10 to the power minus 22 kilojoules, right? The next one, the scientist who disproved Thomson's plum pudding model of atomic structure. Who is he? After Thomson's plum pudding model, what is the next atomic model? Rutherford's nuclear model, right? So therefore, answer is first one. So he is the one who disproved Thomson's plum pudding model. Right. Now let's move to the next topic. Electromagnetic radiation, wave-like properties of matter, quantization of energy, de Broglie's hypothesis of matter, spectrums, and quantum energy levels. X-rays were discovered by Thomson, Becquerel, Roentgen, Marie Curie, Moseley, Wilhelm Röntgen. An atomic nucleus is composed of protons only, wrong. Neutrons only, wrong. Protons and neutrons only. What do you think? Atomic nucleus is composed of protons and neutrons only. Look at the fourth one, protons, neutrons, and other fundamental particles. Students, addition to the protons and neutrons, so there are some other particles also, right? Quarks-like particles. Therefore, answer is number 4. Equal number of neutrons, protons, and electrons. So that is not correct. It can be changed. Okay. So the next one, cathode rays are deflected by a magnetic field. Is it correct? That statement is correct. Cathode rays contain positively charged particles. That's wrong. First one is correct. Second one is wrong. So therefore, answer is number 3. Look at the first statement. A student made the following statements about the atomic spectra of hydrogen. Which of the statement is incorrect? The series of lines in the infrared region of the spectrum is called Lyman series. Students, can you remember Lyman series belongs to ultraviolet region. Balmer series belong to partly visible light region. Then Paschen, bracket, fund, they belongs to IR region. So therefore, telling that Lyman series belong to infrared region is wrong. Each line in the spectrum corresponds a definite radiation. Yeah, that's correct. Because we know that in the hydrogen emission spectrum, each spectral line is representing that when the electron is going to high energy levels, when they are coming back to low energy levels, it will release energy. So energy radiation. So therefore, that is the spectral line. The series of lines in the visible region is called Balmer series. Correct. The principal lines in the Balmer series are named as H alpha, actually they have to give this is H alpha, beta, gamma, and delta. Okay. We know that in the Balmer series, we have 4 lines. In this way, right? This is H alpha, H beta, H gamma, H delta. H alpha is red color. This is green color. This is blue and violet. Okay. The atomic spectrum is caused by transition of electrons between the energy levels. That is also correct. So therefore, here incorrect statement is first one. Fourth question, answer is number 1. Cathode rays penetrate through very thin aluminium foil. Is it correct? Yeah, cathode rays can penetrate. Cathode rays consisted of alpha particles. That's again wrong. First statement is correct, second one is wrong. So therefore, answer is number 3. Which of the following statements about alpha particles are true? Alpha particles have high penetrating power than beta particles. Wrong. Alpha particles have high ionizing power. Correct. Than beta particles. Alpha particles produce helium gas. Can it produce helium gas? I told you that alpha particles means helium nucleus. Once this helium nucleus gaining 2 electrons, it can produce helium gas. Can produce. Alpha particles are not deflected by a magnetic field. Wrong. It is deflected. P and C statements are correct. Therefore, answer is number 2. The ionizing power of alpha particles is greater than the ionizing power of beta particles. Correct. That's correct. The mass of the alpha particle is very much greater than the mass of beta particles. That is also correct. Now, we met this kind of a statement earlier, right? Students, why alpha particles are having that much of ionizing power? Because of its charge. Remember that. Because of its charge. It is +2 charge. Beta means -1 charge. The quantitative value of the charge is greater in alpha than the beta. So therefore, they can ionize. They can ionize the gases easily. So therefore, it's not the mass factor, it should be charge factor. But both the statements are correct. Both the statements are correct. Second statement is not clearly explaining the first one. Therefore, answer is number 2. Which of the following statement is are true? In a strong magnetic field, beta rays are attracted towards the N magnetic pole. No. Second one is S magnetic. Wrong. In an electric field, alpha rays are repelled by the positively charged plate. That's correct. Because alpha particles are also positive. Then they are definitely repelled by positive. Because positive repulsions will create. In an electric field, gamma rays are not attracted towards the negative charge plate. Yes. Gamma rays are having no charge. So therefore, they are not deflecting. They are going in the same path. C and D statements are correct. Therefore, answer is number 3. Right? C and D statements are correct. Therefore, answer is number 3. Right. Which one of the following patterns of lines is most closely connected with the protons of lines of the atomic spectrum of hydrogen? What do you think? According to these line pattern, students, right? Can you remember we learned the hydrogen emission spectrum? Among these given line patterns, which one is correct as you think? The first one is a line series, one particular line series. They are having the equal gaps. Then that's wrong. No? Then in the second one, you can see three series are there, but the gap between the lines are same. Then that cannot be taken. Then the third one you can see there are two different series. In this series, you can see that the gap is increasing for the right side, but here in the second series you can't see the gap between the last three lines. So therefore, it is not a correct pattern. And again, you can see in the fourth one, you can see the gap between the lines are equal. So when you draw the spectral line pattern, we know that look at this. The gap between the lines are decreasing for a particular direction. See, then the next line series should be like this. Okay. Oh, so we can say this is Lyman, Balmer, right? So the next one is partial. So for a particular direction, the gap should decrease in each series. So we don't see any kind of correct pattern of line series in the given answers. Ne? None of the above patterns of lines is closely connected with the patterns of lines of the atomic spectrum of hydrogen. Yes. Answer is number 5. We don't have any correct pattern of spectral lines. The charge that can exist on a cathode ray particle was quantitatively determined by whom? Millikan, but Millikan's name is not mentioned. Again, none of the above. Question number 11. Which of the following statements concerning alpha, beta, gamma rays are correct? The path of alpha rays is changed by magnetic fields. Is it correct? Yeah, that's correct. Path is changed. The path of beta rays is changed by electric fields. Is it correct? Definitely. The ionizing power of gamma rays are very high. Wrong. Ionizing power is high in alpha rays. Penetrating power of alpha rays is high. Wrong. Okay. So therefore, here A and B statements are correct. Therefore, answer is number. Right. Students, let's have a small break. I'm going to start the class at 11, okay? Right, okay. Let's start. Now MCQ number 12. The penetrating power of beta rays is very high. Is this correct? The penetrating power of beta rays is very high. No, that's not correct, because penetrating power is very high in gamma rays. Beta rays are electrons traveling at high velocities. That's correct. Because we know that beta rays having the speed 90% of velocity of light, right? First statement is wrong. Second one is correct. Therefore, answer is number 4. Then question number 30. Which one of the following statement concerning alpha particles is not true? The penetrating power of alpha particle is low. Correct. The ionizing power of alpha rays is high. Correct. Alpha rays travel with a velocity which is almost equal to the light. No, wrong. The path of alpha rays is changed by electric fields. Correct. The path of alpha rays is changed by magnetic field. Correct. So therefore, they're asking the statement which is not true. Therefore, answer is number 3. Which of the following statement concerning certain isotopes is or true? Remember, students, oxygen 18 radioactive, fluorine 19 radioactive, phosphorus 32, cobalt 60. Phosphorus 32 and cobalt 60, they are radioactive. C and D correct. Therefore, answer is number 3. Remember that. Cobalt 60 is used to treat the cancers also in hospitals. So therefore, it is radioactive. So phosphorus 32 is also radioactive. Next question. Question number 15. Question number 15 is similar to the question number 9 that we discussed, no? Yeah. Which of the following patterns correspond most closely with the position of lines of the spectrum of atomic hydrogen? Is there any correct pattern that we can see? Let me start from the 5th one. So you can see that for this direction, the gap is decreasing. And here the gap is decreasing for the other direction. So then it's not correct, no? You can see that in here, this line spectrum is having the equal number of the equal spaces. Therefore, can't be considered. And the third one also, you can see that between the lines, equal spaces are there. And here you can see that in the second one. Yeah. Question number 13 answers third one. 14 answers also third one. Right. 12 answers fourth one. Right. Now, in the second one also, you can see that the lines, the gap is decreasing, no? For two different directions. So it can happen. But if you consider first diagram, here you can see that gap is decreasing for this direction, gap is decreasing for this direction. So therefore, the first one is the correct option, right? It's kind of Lyman and Baum. Question number 16. Which one of the following statements concerning atomic spectra is true? As the frequencies of the lines of the spectrum of hydrogen increases, the lines rapidly come close together. Yeah, that statement is correct, students, right? So when I consider this spectral line diagram, if you can remember, we learned in the theory class for this direction, right? Energy and frequency both increase. Energy and frequency both increase for the direction where the gap between the lines are decreasing. Can you notice that? Energy and the frequency increasing for the direction where the gap between the lines are decreasing. No? So they have given the same statement. As the frequencies of the lines of the spectrum of the hydrogen increases, the lines rapidly come close together. Correct. That's correct. As the frequencies of the lines of the spectrum hydrogen increases, the line move away from the nucleus, away from each other. That is wrong. The frequency difference between successive line in the spectrum of hydrogen remains constant. What do you think? The frequency difference between successive line in the spectrum of hydrogen remain constant. All right. What do you think about this? The frequency difference between the successive line in the spectrum of hydrogen remain constant. No. Frequency difference is not remaining constant. Energy difference, frequency difference is changing. Right? It is changing. Hydrogen gives only an emission spectrum. Wrong. Only an absorption spectrum. No. We discuss about both emission and absorption spectrum. So therefore, question number 16 answers first one. Students, you can see that in these questions, they're asking just simple theories, okay? They're asking what you learn in the theory class. Very simple, right? We have discussed even difficult questions in our memory booster papers, okay? Which of the following statement concerning gamma rays is true? Gamma rays travel with a velocity of 95% of the velocity of light. Wrong. Gamma rays are electromagnetic radiations. Actually, gamma rays are traveling with the velocity of light, not 95% of velocity of. Beta rays only traveling with the 95% of. Actually, it is not. Yeah, 90%, 90 or 95% of velocity of light. That's wrong. It's not gamma rays. Gamma rays actually they are traveling in the velocity of light. The ionizing power of gamma rays is very high. Wrong. The penetrating power of gamma rays is very high. Correct. The path of gamma rays is not altered by magnetic fields. Correct. Because gamma rays are neutral. C and D statements are correct. Then what is the answer? If C and D statements are correct, what is the answer? Answer is third one. Which of the following statement is true? Electric fields do not affect the path of cathode rays. Wrong. Changing the path. Magnetic fields do not affect the path of cathode rays. Wrong. Electric fields do not affect the path of fast moving neutrons. Correct. Magnetic fields do not affect the path of fast moving neutrons. Correct. Because neutrons means neutral particles. Whether it is fast moving or uh, just moving, so it doesn't matter, they are neutral. So in the presence of an electric field and magnetic field, remember, always the charged species only getting deflected, right? C and D statements are correct. Therefore, answer is number 3. MCQ number 18, answer is number 3. MCQ number 19. Cathode ray particles are negatively charged. Travel in straight lines, correct, are attracted towards N pole, S pole, no. A, B correct, answer is number 1. If A and B statements are correct, answer is number 1. Easy. Question number 20. Which one of the following statements pertaining to atomic spectra is false? Atomic spectra can be studied as emission spectra. What do you think? Atomic spectra can be studied as emission spectra. Yeah, nothing wrong with that. We can study emission spectra. Atomic spectra can be studied as absorption spectrum. Yes, the spectral line of an atomic spectrum occurs as several clearly distinguishable series of lines. Exactly. Lyman, Balmer, Paschen, Brackett. So those are the things that we learn. The dark lines of an absorption spectrum do not occur as several clearly distinguishable series of lines. Why not? Clearly we can see dark lines as several distinguishable series of lines. Right? So we can't accept this statement. There is no direct relationship between a given height of line of an atomic spectrum and a certain energy level in the atom under consideration. No, there is no relationship between the height of the spectral line and the energy level. There is no connection at all. Right? So we know that a spectral line is representing difference between the energy levels. That's all. So here they are asking the false statement. Answer is number 4. The E/M ratio of cathode rays was first shown to be a constant by Rutherford. (22) Which of the following statement is true? Alpha particles are attracted towards the atomic nucleus. Is this correct? No. Alpha particles are actually deflecting from atomic nucleus because atomic nucleus is positively charged. Alpha particles are also positively charged. Cathode rays are not attracted towards S pole of a magnetic. Yeah, we can say that's correct. Cathode rays actually moving perpendicular direction of the magnetic field. Positive rays are not attracted towards the N pole of a magnetic. B statement is correct, no? C also correct. The velocity of alpha rays is greater than the velocity of X rays. Remember, alpha rays are having velocity of 10% of light. Velocity of X-ray, we know that X-ray means electromagnetic radiations. So that is velocity of light. 3 into 10 to the power 8. Then X-rays are having high velocity. Then saying that velocity of alpha rays is greater than the velocity of X-rays, wrong. B and C statements are correct. If B and C statements are correct, answer is number 2. MCQ number 23. The emission spectrum of hydrogen atom and emission spectrum of lithium atom are very closely similar. No, no, no. Hydrogen is containing 1 electron. Lithium is containing 3 electrons. Can you remember after the discussion of the emission spectrum, I told you that hydrogen emission spectrum or any emission spectrum of a particular element is unique for that element, right? Even though there are same number of electrons in a species, their line patterns are same, but the energies can be different. So therefore, very closely similar for hydrogen and lithium is, that's a wrong statement. Hydrogen and lithium have only 1 electron in each of the outermost energy levels. Yeah, that's correct. Now, lithium is having 1 electron in the outermost energy level is correct. Total number of electrons are 3. But in the outermost energy level means what? Outermost energy level means valence shell. Valence shell of lithium is containing 1 electron. That's correct. And hydrogen is containing anyhow 1 electron. So therefore, that statement is correct. First one is wrong, second one is correct. Therefore, answer is number 4. Now let's move to the MCQ number 24. Which of the following statement is correct regarding the atomic emission spectrum of hydrogen? Right. So, shall we draw the emission spectrum? Hydrogen emission spectrum. We discussed this one in the theory class in detail. So these are the energy levels, right? Lyman series. All the electron transitions which are taking place to the first principal energy level. In this way, so this is partial, right? Lyman belongs to ultraviolet region. Balmer belongs to partly visible light region. Then Paschen belongs to IR in this way, right? Then you can draw the corresponding line diagram also. So this is the energy level diagram that we learned. Okay, right. Now let's move to the question. So we can see that the question they have given is the radiation corresponding to the n equal 2 to n equal 1 transition has the longest wavelength. That's wrong. It is the longest, that is the largest frequency, not the wavelength. Because energy gap is n equal 6 to n equal 1 according to the diagram that we drew. Now here they have given the radiation corresponding to the n equal 2 to n equal 1 transition has the longest wavelength, right? So we can't say that, no, that's wrong. That's wrong. Then n equal 3 to n equal 2 transition corresponding to H alpha. N equal 3 to n equal 2. So where is 3 to 2? Yeah, that is H alpha, no? Correct. This is H beta, H gamma, H delta. Second statement is correct. Yes. Second statement is correct. What about the next one? The first series of the lines, Lyman occurs in the infrared region. Wrong. Lyman occurred in the ultraviolet region. In the given series, the separation between adjacent lines increases in the direction of increasing energy. In a given series, the separation between the adjacent lines increases in the direction of increasing energy. No. Can you remember the gap between the lines are decreasing for the direction where energy and the frequency increasing, right? They have given in a given series, the separation between the adjacent line increases in the direction of increasing energy. No, it is decreasing energy. Emission of radiation occurs when electrons undergo transition to highest levels to the lower levels. We know that when the electrons are moving from low energy level to high energy level, it is absorption. If the electrons are coming back to the low energy levels, we consider them as emission. Okay. So they have given emission of radiation occurs when electrons undergo transition to higher energy levels from lower levels. Wrong. So here answer is second one. MCQ number 24, answer is second one. The next one, MCQ number 25. Which of the following statement is or not true regarding the atomic spectrum of hydrogen? The transition from n equal 5 to n equal 2 corresponding to the H beta line. Students, n equal 3 to 2 is H alpha, 4 to 2 is H beta, 5 to 2 is H gamma. This is wrong. The energy difference between n equal infinity to n equal 1 levels is the ionization energy of hydrogen. Yes, exactly. Correct. Each line in the spectrum corresponding an energy level of hydrogen atom. No. Each line is representing between the energy levels. The energy difference between n equal 2 and n equal 1 levels is smaller than the energy difference between n equal 3 to n equal 2. So try to understand 2 to 1 difference and 3 to 2 difference, right? So this is the 2 to 1 difference. Okay. And this is the 3 to 2 difference. Then which one is larger? 2 to 1 difference is larger. So therefore, the given statement is again wrong. The last statement that they have given is wrong. Okay. So they're asking which of the following statement are not true. A, B, D. Sorry, A, C, D. A, C, D. There is no option like A, C, D. Therefore, I'm going to take the all. Okay. In the A-level examination also, if there are no answers for a question, they are giving all in the marking scheme. Right. Now let's move to the MCQ number 26. The order of filling electrons into energy levels. The atoms in the fourth period of the periodic table is. So, what is the electron filling order? Can you remember Aufbau principle? Let's revise Aufbau principle. Aufbau principle of electron filling order. One S, two S, two P, three S, three P, three D, four S, four P, four D, four F, five S, five P, five D, six S, six P. One S, two S, two P, three S, three P, four S, 3D, 4P, 5S, 4D, 5P, 6S, right? So this is the Aufbau principle, the line electron filling order. Right? Then, so we can say 4S, 3D, 4P. Answer is third one. Electron filling order. Right. MCQ number 27. Which of the following correctly represents the arrangement of the emission lines into a consecutive series in the atomic spectrum of hydrogen? Uh, which one is the correct one? So third one cannot be taken. Can you see that the gap is same? And the fourth one, here you can see that the gap between the lines are decreasing. Now here also, here gap is decreasing for this direction. This direction can't be taken. What about the second one? What about second one? Yeah, this is okay, no? Second one is absorption. No, this is actually a emission spectrum of hydrogen, okay? Stuart, they have given emission lines. You have to analyze the gap between the lines very carefully and the separation of the series. Here, this is one particular series, and here, this is another one. And here we can say this is another series. Seems that both are correct. For a particular direction, the energy should decrease. Yeah. Since the gap should decrease for a one particular direction, first one is the correct one. Can you see the gap between these two lines are very high, but in the next series, the gap between the first two lines are very low. It should decrease in that way. First one is the correct one. Right. Now, question number 28, we can see that the emission lines of the Balmer series of the atomic spectrum of hydrogen are shown below. Yes, this one should be red, green, blue, no? Because you can see that the gap between the lines are decreasing for that direction, which means for that direction, energy and the frequency is increasing. When you consider red color, green color, blue color, and the violet color, which one has the highest frequency? Violet. Understood? Then lowest frequency, red color. Then A is red color, B is green color, C is blue color. Right. So the next MCQ, the color imparted on the Bunsen flame by metal atoms uh, from the first energy release when electrons return to the ground state from the first excited state. The flame colors of some atoms are given below. Uh, can you remember the flame test colors that I gave you? What is the color of lithium? Lithium is red. Copper is green color. Sodium is yellow color. Potassium is lilac. So you know that which color has the highest frequency? Lilac. That means potassium. Okay. Then the next one, green color. After that, yellow. After that, red. So therefore, we can say that easily answer is fourth one. Right? So you can just know the frequency of colors. Which of the following statement is true? Bohr theory is a nuclear model of the atom. What do you think? Bohr theory is the nuclear model of the atom? No, that's wrong. Bohr theory is explaining the existence of the energy levels. That means it is explaining the path of the electrons. Rutherford proposed the first nuclear model of the atom. Correct. Electrons do not behave as waves and particles at one and the same time. What do you think? Can electron behave waves and particles at the same time? They have particle nature and wave nature, but not the same time, right? E of M ratio of cathode rays varies with the gas inside the cathode ray tube. No, it's not correct. E of M ratio is a constant, whatever the gas that we used. B and C statements are correct. Therefore, answer is second. The atomic spectrum of hydrogen is a line spectrum. Yeah, that's correct. The energy associated with each line of the spectrum is equal to the energy of the electronic level corresponding to the line. The energy associated with each line of the spectrum is equal to the energy of the electronic level corresponding to the line. We know that energy associated with each line is representing the energy gap between the energy level. It's not the energy of energy level. First one is correct. Second one is wrong. So therefore answer is third one. MCQ number 32. Which of the following statement is true? Positive rays are formed when an electron is removed from a gas in a cathode ray tube. Positive rays are formed when an electron is removed from a gas in cathode ray tube. Is it correct? Yes. Cathode rays originate from the cathode. Correct. Positive rays are originated from the anode. Wrong. Positive rays are generated, we know that, at the middle of the cathode ray tube. That means in the path. Cathode rays are a type of electromagnetic radiations. No. A and B statements are correct. Therefore, answer is number 1. MCQ number 33. Which of the following pairs of lines has or have a difference between them which is equal to third and fourth lines in the Lyman series of the atomic spectrum? So third and fourth line of the Lyman series. So where is the third and fourth? So this is the third, fourth. So we can say that this is the gap they are talking about. Then in the Balmer series, we can say that this gap is in between second and third lines. And in the Paschen series, first and second line. Okay. In the Lyman series, third and fourth line. In the Balmer series, second and third one. In the Paschen series, first and second one. So therefore, third and fourth lines of the Balmer series wrong. First and second line of the Paschen series is correct. Second and third of the Balmer series is correct. Third and fourth of the Paschen series is wrong. B and C correct. Therefore, answer is second one. Now MCQ number 34. Electrons behave sometimes as particles and sometimes as waves. Electrons have both particle and wave properties. This is correct. But students, this is wrong. Okay. Sometimes they can behave as particles and waves. Answer is number 4. Okay. A sample of hydrogen atoms excited in a flame has electrons distributed 1 to 5 energy levels. How many different wavelengths of radiations are emitted by the sample according to the Bohr theory? Now, if there are 5 energy levels, now just imagine this diagram I have drawn only up to 6th principal energy level. Now, just imagine the 6th principal energy level is not there. Then this line is missing. This line is missing. This line is missing. Then how many transitions that you can see? If there is only 5th principal energy level, up to 5th principal energy level, 1, 2, 3, 4, 5, 6, 7, 8, 9. 9, and we know that, look at this. Even we can consider bracket series, another line is there. So these are the possible electron transitions. 10 electron transitions are there. Okay. 10 electron transitions are there. Right. Okay. Students, I think today we discussed a lot of questions. I will send you the PDF of this one, the handwritten PDF also. And you do the remaining questions. You will get the tutorial very soon. Physical students will get the tut next week, and online students also will get the tut next week. So in the next week class, we are going to discuss page number 14, MCQ number 36 onwards. Probably we can start electronic configuration and quantum numbers calculations also, right? Raise your hand those who understood the things that we discussed today. Is everything clear? Right. Then let's discuss the remaining questions in the next week class. Get ready for do the remaining questions also and redo these questions. And if you have any doubts, let me know, right? Okay. Then let's meet on the next week class. Until then, bye bye. Have fun. Good afternoon for all of you.